Hey there, and welcome back to the craziest science class on the internet. Today, we're embarking on an epic journey, a quest to understand one of the most fundamental and fascinating transformations in the universe, turning movement into electricity. That's right, we're talking about kinetic energy becoming electric energy. Now, before we dive into the deep end, let's get a handle on what kinetic energy actually is. Put simply, it's the energy of motion. Anything that moves has kinetic energy. A car speeding down the highway, a bird flying through the air, a meteor hurtling through space. They all possess kinetic energy. Even you, right now, just by breathing, are creating tiny movements that have kinetic energy. The amount of kinetic energy an object has depends on two things: its mass and its speed. The heavier something is, and the faster it's moving, the more kinetic energy it has. Think about it. A bowling ball rolling slowly has some kinetic energy. But a bowling ball shot out of a cannon, that's a whole different level of energy. The formula is pretty straightforward. Kinetic energy equals 1/2 times mass times velocity squared. Don't worry, there won't be a test, but it's cool to know that speed plays a huge role. Doubling the speed actually quadruples the kinetic energy. So, we're all constantly generating this energy. Every step you take, every time you wave hello, every frantic dash to catch the bus, you're a little powerhouse of kinetic energy. The big question is, how do we capture this free-flowing energy and turn it into something we can use, like electricity, to power our phones or light up our homes? This is where the magic of physics comes in, specifically a principle called electromagnetic induction. It sounds complicated, but the core idea is simple. Back in the 1830s, a brilliant scientist named Michael Faraday discovered that if you move a magnet near a coil of wire, you can create an electric current in that wire. Conversely, if you move a coil of wire through a magnetic field, the same thing happens. This single discovery is the foundation of almost all electricity generation today. So, the challenge is to take kinetic energy, the energy of motion, and use it to either spin a magnet inside a wire coil or spin a wire coil around a magnet. This device, the thing that makes the conversion happen, is called a generator. Let's look at a classic example, a bicycle dynamo. You might have seen these little gadgets on older bikes. It's a small generator with a wheel that presses against the bike's tire. As you pedal, the bike wheel turns, which in turn spins the little wheel on the dynamo. Inside the dynamo, that spinning motion turns a small magnet surrounded by a coil of wire, and voila! The movement of your legs, your kinetic energy, is converted into electrical energy that powers the bike's headlight. It's a perfect, small-scale example of our energy journey. But this principle scales up in a massive way. Think about the huge power plants that supply our cities with electricity. A hydroelectric dam, for instance, uses the kinetic energy of falling water. The water flows down, pushing against the blades of a massive turbine, causing it to spin. This turbine is connected to a giant generator, and as it spins, it generates enormous amounts of electricity. The same goes for wind turbines. The kinetic energy of the wind pushes the blades. They spin a turbine, and the connected generator creates electricity. Even power plants that burn fossil fuels or use nuclear reactions are at their core just very complex ways to create kinetic energy. They use heat to boil water into steam, and that high-pressure steam is then used to spin a turbine connected to a generator. So, no matter the source, that final step of converting motion into electricity through a generator is almost always there. Now, let's talk about the really exciting stuff, the innovative and sometimes downright quirky ways we're restarting to harvest kinetic energy from our everyday lives. The world is buzzing with new ideas, and some of them feel like they're straight out of a sci-fi movie. Have you ever heard of piezoelectricity? It's the ability of certain materials, like specific crystals and ceramics, to generate an electric charge when you squeeze or press on them. This opens up a whole new world of possibilities for capturing kinetic energy. Imagine sidewalks and roads embedded with these materials. Every footstep, every car driving over them, creates a small amount of pressure. That pressure generates a tiny electric charge. All those footsteps combined could generate enough electricity to power the station's lights or ticket machines. In places like Tokyo and London, they've trialed kinetic flooring in high-traffic areas. There are even nightclubs that use the energy from the dance floor to help power the club's lights and sound system. And it doesn't stop at floors. The bouncing motion of the backpack on your back drives a small generator inside, allowing you to charge your phone or GPS while you're hiking. The applications are endless. Think about playgrounds. A company called Pavagen has installed its kinetic tiles in a soccer field in a Rio de Janeiro favela. The players running and jumping generate electricity that powers the floodlights, allowing kids to play safely after dark. It's an incredible example of how this technology can have a real, positive impact on communities. So, what does the future hold for kinetic energy harvesting? This is where our imaginations can really run wild. We're moving towards a world where energy generation is decentralized and integrated into our environment. Instead of relying solely on a few massive power plants, we could be harvesting energy from countless small sources all around us. Imagine your clothes woven with piezoelectric fibers, so every movement you make contributes to charging your personal devices. Your gym workout could do more than just burn calories. It could power the gym's equipment or even feed electricity back into the grid. The vibrations from subways and trains could be captured to power tunnel lighting. The constant motion of ocean waves could be harnessed by buoys that bob up and down, generating clean energy 24/7. We might see self-charging electric cars that regain some power, not just from braking, but from the vibrations of the road itself. Drones could extend their flight time by harvesting energy from wind currents and their own vibrations. Even something as simple as a keyboard could generate power from the typing of your fingers. Of course, there are still challenges to overcome. The amount of energy generated from many of these sources is still quite small. Efficiency is a major hurdle. We need to get better at converting a higher percentage of the kinetic energy into usable electricity. The materials can also be expensive, and integrating them into our infrastructure on a massive scale is a huge undertaking. But the potential is undeniable. As technology improves and costs come down, we're going to see more and more of these kinetic energy solutions become a part of our daily lives. It represents a fundamental shift in how we think about energy, not as something that comes from a distant plant, but as something that is all around us, waiting to be tapped into. The journey from kinetic energy to electric energy is a story of human ingenuity, from Michael Faraday's simple discovery to the futuristic vision of self-powering cities. It's a reminder that the universe is filled with energy, and our challenge is to find clever and sustainable ways to use it. Every time you go for a run, ride a bike, or even tap your foot, you're a part of this incredible energy ecosystem. You are a power plant. So keep moving, keep exploring, and who knows? Your next dance party might just help save the planet. Thanks so much for joining me on this energy adventure today. If you enjoyed this deep dive, don't forget to hit that like button, subscribe for more science shenanigans, and ring that notification bell so you don't miss our next video. Until next time, stay curious.